Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Afizuddin Ramli. Today, in this video, I want to present our lab report. So our experiment is T4 heat pump. So this is the table of content. I will present to you guys about introduction, objective, apparatus, procedure, and data. In the introduction, I will talk about our group members, front page, assessment form, and figure. These are our group members. So the first one is Nik Muhammad Aikal bin Mahasan. The second one is Muhammad Aiman Hakal bin Hamidun, and the third one is me, Muhammad Hafizuddin bin Ramli. Okay, this is the front page of our lab report. And this is the assessment form. This is the figure of heat pump, as you can see. So we have 4 objectives in this experiment. So the first one is to demonstrate the principles of heat transfer and exchanger. The second one is to demonstrate the principles of a refrigeration cycle. The third one is to demonstrate the principles of a heat pump cycle. And the fourth, to use the refrigerant datasheet and pH chart. So this is the apparatus that we use. First one is water heat pump unit. Second, stopwatch. And third, measuring cylinder. So in this experiment, we have 2 parts, part A and part B. This is, as you can see, this is a part A. So and this is the part B. So this is the data that we collect in our experiment. I pass the analysis to Nik Muhammad Aikal.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Haikal bin Mahasan. So I'm going to present about my part is analysis. So for part 1, the first question is find the average heat transfer in the evaporator QL by using the formula QL equal to ME CW delta T C, which is QL is average heat transfer in evaporator, ME is mass flow rate of water in evaporator, CW is specific heat capacitor of water, and delta TC is T temperature out minus temperature in. By using the formula, we can find the heat transfer in evaporator for 5 minutes, 10 minutes, 50 minutes and 20 minutes, and then we need to divide by 4 to find the average heat transfer in the evaporator. Same goes to the average heat transfer in condenser by using the formula QH equal to MC CW delta TC. QH is heat transfer in condenser, CW is specific heat capacitor of water, and delta TC is temperature out minus temperature in. By using the formula, we can find the heat transfer in condenser for 5 minutes, 10 minutes, 50 minutes and 20 minutes, and then divide by 4 to find the average heat transfer in the condenser. So for the third question is find the average COP of the heat pump. COP stands for coefficient of performance. To find the COP, we will use formula COPHP equal to QH, heat transfer in condenser divided by WE, electrical power consumed in compressor, which is fixed 125 volt. And then from the formula, we can find the COP for 5 minutes, 10 minutes, 50 minutes and 20 minutes, and then divide by 4, and we will get average COP of the heat pump. For the part B, we need to find the specific enthalpy H1, H2, H3 and H4 from the figure 2 pH diagram. And then from the data collected, we need to find QL, QH, WE and COP for cycle 1, 2, 3, 4 and 5. To find QL, we need to use formula ME times H4 minus H1, and then for QH, we need to use formula ME H2 minus H3, and for WE, we need to use formula ME times H2 minus H1, and for COP, we need to use formula QH over WE. And here is figure 2 for pH diagram for for cycle 1 and cycle 2, cycle 3 and cycle 4, and the last one is cycle 5.
Now we move to discussion part. What is heat pump? A heat pump is a refrigeration machine that can transfer heat from one location to another. Air conditioner using a vapor compression refrigeration cycle is a heat pump. The heat pump unit consists of compressor, an evaporator, and a thermal expansion valve as shown in diagram below. Heat pumps are considered energy efficient because they move heat rather than directly generating it. They can provide more heat energy than the electrical energy they consume, making them an environmentally friendly and cost-effective option for heating and cooling. Additionally, heat pumps can be used in conjunction with other heating or cooling systems, such as furnaces or air conditioners, to enhance overall energy efficiency. What happened during the experiment? From the experiment, there are no bubbles inside the viewing glass A. It can be observed that the refrigerant R134A is in vapor state. Bubbles are observed in viewing glass B. The refrigerant R134A changed from vapor to liquid state. There are some errors affect the results obtained. Firstly, the water flow rate for entering and leaving the both evaporator and condenser are difficult to adjust till the same rate. The water flow rate will affect the mass flow rates of water. Since the rate flow of water input and rate of flow water output are not the same, the height of the water level will be affected. Mass flow rate will be increased when the height increases and vice versa. To overcome this problem, experimenter must be really focused when adjusting the water flow in order to get the same rate. Secondly, human reaction time in using the stopwatch also contributes to the inaccurate results obtained. To avoid this, experimenter must not playing around during the experiment and react quickly right after the time required. Here are the conclusions and references for this experiment. The last part of this video is data verified. Thank you for watching this video.